Okay, we are moving on. We are into review 2A, and you can kind of see that the problem numbers are, increasing. And so those, as you go through the test, typically it just gets a little bit tougher as you go through these. And so you want to make sure you're spending your time correctly on here. And if there's something that you get stuck on, you don't want to spend too much time on one problem. Okay, so you're starting to think about that. Let's see what we have here and see if we can kind of do some of these problems here. So number 7. Says, for what value of k does the expression x plus k over x have a relative max? Okay, and k is just some number. It could be 3 or 4 or 8 or pi or whatever that we're trying to figure out, some constant. And does it have a relative max? And so the idea would be, as I see it, you would see f of x equal to x plus k, x to the negative 1 power is our function. We want to take the first derivative of that function. Then we 1 minus k, x to the negative 2. Okay, and then set that equal to 0. We're trying to find a relative max. Okay, so if you set that equal to 0, 1 minus k over x squared equal to 0. And solve for that. Well, I'm sorry, we can't solve for that, but that's one item that we have. We can solve for that if we put in negative 2 in for that x. And if you do that, you end up with a k value of 4. And then that would be your answer. Let's keep moving on here. 11 is a good problem. 11 says the point on the curve that is nearest, so we kind of nearest, all of a sudden that means our relative max and min are optimization problems there. And so if you kind of think about this curve that we're looking at is y equals negative 1/2 x squared. Okay, and so that is a parabola going down. Sorry, a little sloppy here. Supposed to be hitting the origin. And there's a point 0, negative 1/2. Okay, and we are looking for the point on the curve that is nearest that. So we're trying to minimize that distance, d, is what it comes down to. Okay, so we're trying to minimize something. We have a function. We're trying to figure out that distance function there. And we'll try to minimize that. Well, let me get rid of this for a second here. And so we're trying to minimize the distance. So we need some sort of distance formula. We have 2 points. Okay, and so our 2 points here, so we had y equals negative 1/2 x squared. A point on the parabola could be represented by x comma, excuse me, negative 1/2 x squared. That would be the y value at that particular x. And so our 2 points are 0, negative 1/2, and then the x comma negative 1/2 x squared. We can figure out the distance between those 2 points. That's a square root formula. So x minus 0 squared plus negative 1/2 x squared plus 1/2 squared. That's supposed to be a squared up there. Oh, nice. And we're trying to minimize this. Now, what I do, you could square both. I mean, we want to find the first derivative of this function d. I'm going to tell you that it's going to be a lot easier if you view it without the square root. Okay, and that's going to be the part that you are going to find the first derivative of anyway. That's going to be the important part, is finding the first derivative of what's inside. This is the part that's what's inside that we want to find the first derivative of. Okay, and so we're going to find a first derivative of this new q function, okay, which was the inside of the distance function. Okay, so if you had done the first derivative of the distance function, you would end up with this anyway, and so that's what you're going to use. It's going to be a lot easier. This is kind of a common problem. The point on the curve that's nearest another point. This might be one of those problems that you star because it happens fairly often. And let's see what we have here. If we take this q value, that's going to be x squared. You multiply this all out, you should end up with x squared plus x to the fourth over 4 minus x squared over 2 plus 1/4. You end up with a first derivative that should be x to the fourth over 4 plus x squared over 2 plus 1/4. I skipped a step there. You got to put the x squares together. Okay, but you should end up with that first derivative. Sorry, I said that wrong. That's not the first derivative yet. It took me a second there. That is still my original function. I'm sorry, I am showing that actual step there. I did not skip it. Just kind of looking at my notes there. So those two come together for that. Now we're taking our first derivative. So our first derivative comes up with x cubed plus x. And so once we get to that, we're kind of happy that we have something so simple after all those fractions. And so you're going to set that part equal to 0. That would be x cubed plus x. Set that equal to 0 and solve. And you'll end up with x and then x squared plus 1. That's going to give you an I number, so your answer is x equals 0. And finally you get to that answer. Okay, so that would be a common question. You know, a common scenario there. Find a point on the curve that's closest. You can kind of go through those steps that we did there. And we're going to keep moving on here. Okay, let's look at that number 15. And this is a thought question there that's a little bit tough to figure out. And if you can't zero in very quickly on this, this would be one you would want to skip. Okay, as I see this, as I'm kind of reading this, I would say these two first derivatives exist. That means they're slopes. Their slopes of those functions exist. Those are numbers. It doesn't go vertical. Okay. The slope of the f function is greater than the g function. It's steeper all the way through the graph. Then the graphs of y equals f of x and g of x. Now, how many times do they intersect? It's kind of hard to figure this out, but you could have a graph. Okay, so let's say this is that's the steeper one. That's f of x is steeper, okay, than g of x. Okay, for all values, g of x could be like that. Okay, and you can see they would intersect in 1. Or no, I mean there could be intersect no more than once would be your answer. Okay, it's going to be your answer there. But that takes a little thinking to go through that to see that scenario. But that's a little bit of vision into how that works there. 17 point of inflection, and so you've done that. You see that problem, and that may be more comfortable to you than the previous problem. So you would want to take your time and solve this and do it correctly. You end up with B as a final answer. Okay. Let's keep moving on. We'll go on to the next page. And this is review 2B. We're going to continue on here. 18 there, you have this Absolute value, another one of those common things. Absolute value is a weird function in that it is not super well defined. You don't have a formula for finding the first derivative of an absolute value function, and in fact, it doesn't have a first derivative at its point. Okay, so remember this is a V pattern, and that slope of the tangent line through that does not exist. Okay, so since 3, when you plug it in, gives you 0 inside. The absolute value, that's where that turn occurs, and there is not a derivative at that point. There's not a tangent line at a point like that. Okay, so that's a sharp point. It's not a parabola, it's a sharp point. So that's does not exist. And then moving on to number 10, and attains its maximum value. Thinking you're comfortable with that, that would be an answer 1 eventually. And then 22, looking at concavity. Okay, that's finding the second derivative and making the second derivative chart to figure out the concavity. And you have to kind of look at the notation here, what they use, but your answer is going to end up being B. Okay, I have both of those as straightforward problems. If you had questions with those, you could get some help on that. And then number 39. Well, that didn't work. Sorry about that. Let's see if I can do this. Sometimes this works, sometimes it doesn't. All right, we're having a little problem with that. So we'll try one more time, see if I can erase that, and it's not. There we go. All right, problem number 39. We just saw one just like this. Okay, so the point on the curve nearest to 4, 1. I'll let you kind of work through that. It does take a little bit of time. Okay, to do this, you want to find out a distance curve or a distance formula here. So this is the distance between 2 points. Okay, and then typically we're just going to look at the inside part there and go with that as a new function. Q is what I call it, and move on from there. You can look at the problem we just did just a little bit ago, and you should end up with an answer of 2, 2. And there you go.